So right now we're going to go ahead and find some square roots, and what I've done right here is I've just copied and pasted a perfect squares chart. Perfect squares are just numbers that you square. You raise to the power of 2. So 1 to the power of 2 is 1. 2 to the power of 2 is 4. 3 to the power of 2 is 9. 4 to the power of 2 is 16. 5 to the power of 2 is 25. 6 to the power of 2 is 36, and so forth. So the reason why that I'm giving you these is because squaring and a square root are opposite operations. So squaring a number and taking the square root are opposite operations. Now, what do I mean by opposite operations? Opposite operations undo each other. They are the opposite of each other. So if I said, what's the opposite of adding 5? The opposite of adding 5 is subtracting 5. What's the opposite of multiplying by 5? Oh, well, dividing by 5. So what is the opposite of squaring 5? Oh, well, that's taking the square root of 5. So that's what I'm saying right now. It's just taking the opposite operation. So watch this here. The square root of 49. Okay, so this is what this means when we're taking the square root. The square part of it means this. This is what this problem means. This is telling us to do this. It's telling us to say what squared is 49. That's what this problem means. The square root of 49 means, what did I square to get 49? Well, if I come over here, what number do I square to get 49? Oh, well, 7, right? 7 squared is 49. So 7 squared is 49. So the square root of 49 is just 7. Right here. This means what squared is 1. So what times what is 1, right? Because when I square it, it means I multiply something by itself. So what times what is 1? Well, wouldn't it just be 1, right? So the answer is 1. Okay. Going on to part C. The square root of 16 over 25. So the way that this works here is you can write this as two radicals. You can say the square root of 16 all over the square root of 25. So the square root of 16 is 4, and the square root of 25 is 5. Now, I just want you to notice something, is that if I say the square root of 16 is 4, then I can go backwards by saying, okay, now square 4. If I square 4, I get 16. And if I square 5, I get 25. So really, you can check to make sure that you've done your square root correctly by just squaring your answer. Okay? This guy right here, the square root of 0.0121. Well, if you look at 121, that's 11 squared. So the square root of 0.0121 is going to be 0.11. You say, what, dude? Meaning, if I multiply 0.11 and if I square that, I should get 0.0121. And I do. So that's how I know that. The square root of 196, that's going to give us 14 squared. So the answer is just 14. The square root of 196 is 14. And if I square 14, I get back my 196. Now, the square root of negative 81. Let's just check this out to see if this makes mathematical sense. This right here means what squared is negative 81, right? I taught you what this means. So what number can I plop into here that's going to give me a negative 81? Well, if I think it's 9, is 9 squared negative 81? Is that true? Well, no, right? That's false right there. And if I try negative 9, what's negative 9 squared, right? It's negative 9 squared. You square the whole thing in here. Well, negative 9 squared, is that equal to negative 81? Oops, 81 right there. Is negative 9 squared equal to negative 81? And again, that answer is also false. And really what the answer to this is, it's not possible. You can't square a number and get a negative number. It doesn't make sense, because when you multiply something by itself, if I multiply two positives or if I multiply two negatives, I'm always going to get a positive answer. So anytime that you see a negative sign inside of the radical, okay, this is called the radicand, but it's really not that important. But just basically, if you see a radical underneath the square root symbol, you're just going to say it's a non-real answer. And we haven't talked about non-real answers, complex numbers. That's not going to be until later on. So the only thing you say, this is not a real answer. There are no real answers for this.